All right, class, so in this video, we are going to be going over subsets. So in the previous video, we talked about what are sets, and now we're going to be talking about subsets. So to start off, I'm just going to go ahead and introduce you to the new symbol we're going to be seeing. The way you read this is set A is a subset of set B. So from now on, when you see this symbol here, this represents subset. Now, what in the world is a subset, right? So a subset is kind of like a little piece that you take out of a set. So a subset, like A of B, is going to be a subset if every element in A is an element of B. And if that makes no sense, don't worry, we're going to do an example right now. So if I give you a little piece, like a little set, and I ask you, is this little set a subset of the big one? It's pretty much like if I were asking you, is a little piece of the big one. So if there's an element in there that is not in the original set, then it's not a subset, which is what we're going on to here. So again, this one represents subset, and then when I put a line across it, that means that it's not a subset. That means that there is one element that does not come from the original set. Okay, so just be ready to see those symbols throughout today's video. Again, subset and then not a subset. If you are confused, no need to pause and go back. We're going to be looking at an example right now. So let's go ahead and take a look at this, right? I give you two sets. So you have set A and set B. Set A contains the elements cat, dog, and sheep. And then set B contains the elements cat, dog, sheep, and mouse. The question is set A a subset of set B? So all we have to ask ourselves is, and I'm going to go ahead and write it down, is every element in A also an element of B? So is set A a subset of set B just means is A piece of B? So to check that, I'm going to check here, right? So cat is there, dog is there, and sheep is there. That's all we care about. So since all the elements in A are also in B, the answer to this question is yes. So set A is a subset of set B. That's all you have to do, right? It's super simple. Again, we want to look fancy, so we use the subset symbol, right? So A is a subset of B. So you see, I told you it wasn't that bad. All right, let's go ahead and try this one here. So same question, is set A subset of set B? So set A has 2, 4, 6, 8, and set B has 1, 2, 3, 4, 5, 6, 7. So what do you think? Is set A subset of set B? All we have to do is just check. So 2 is there, 4 is there, 6 is there, but there is an element in A that is not an element of B. So I'm pretty sure you already answered the question. The answer for this one would be no. It's not a subset of B. Because again, there is that little element, which in this case is 8, that is not part of the bigger set. Okay, so again, pretty straightforward. Just make sure you know the difference between the symbols, right? So when we do have a subset, it's the original symbol. When we do not have a subset, then we put a little slash through it. So that's kind of the introduction to subsets. Now, we're going to throw a new symbol in here and don't get confused. We have subsets, and then we have what we call proper subsets. Okay, if I lose you here, just hang on. When we get to the example, it will make a lot more sense. Proper subsets. So if you remember, this right here is the symbol for subset. And now this symbol right here is the symbol for a proper subset. Okay, so what in the world is a proper subset? There are two conditions. Again, if you get lost, don't worry. A proper subset is, first of all, it has to be a subset. Okay, and we already talked about it. So that means that every element in A has to be an element of B. So if it meets the first condition, you're going to check the second condition. The second condition is that it cannot be equal to the second set. So a proper subset, in my own words, I would say it's a piece of the bigger set, but it's not the whole set. So if you want to write that down, I think it makes a little more sense than what we have here, but it's the same thing. So again, a proper subset is a piece that comes from the original set, but it's not the whole set. So just remember that. So we're going to be using this symbol for proper subset. And just like we have been doing before, if it's not a proper subset, we just do a little dash through it. That denotes that it's not a proper subset. Okay, so let's try some examples here. Here we have two sets, right? Is set A proper subset of set B? So like I told you, it has to meet two conditions. The first condition, it has to be a subset. So let's check. So there's a W here, there's a Z there, there's a Y there, and there's an X. So it meets the subset condition. It is a subset. We already checked. But the question is asking us is it a proper subset? So again, it is a subset because it's a piece of the other one. But is it proper? Remember what I told you. For it to be proper, it cannot be equal to the other set. So if you notice these two, they're exactly the same. So it's not only a piece, it's actually the whole thing. So it is a subset, but it is not a proper subset. Okay, so I'm really hoping it made sense. If it didn't, don't worry, we have one more example to go just to see if it clicks. But again, you have two conditions. First, you have to check it has to be a subset, meaning that every element here is also an element here. But for it to be proper, it cannot be exactly the same. Okay, it could have chunks of it, but it cannot be the same thing. So that's why the answer for this one was no. And again, to be fancy, we use the little symbol right there, which is proper subset with a little slash on the middle, right? So it's not proper. All right, let's go ahead and try one more here. Here we have two sets again, right? So set A has cat, dog, sheep. Set B has cat, dog, sheep, mouse. And they're asking us, is it a proper subset? Okay, so we already did this problem earlier when I asked you, is it a subset? And it was. So it is a subset again because look, cat, dog, sheep. So it is a subset, but now they're asking us, is it proper? So all you have to check is, are these two exactly the same? The answer is no, right? B has an extra element. So since they're not exactly the same, this one is proper because it's not copying the other set entirely. So we use a notation of proper subset, which is right here. So A is a proper subset. Okay, so if I'm confusing you, just go back and look at these two examples. Just stare at them. The one we did earlier, they are not, or it was not a proper subset because these two sets were exactly equal. They're exactly the same set. So there's no way it could be proper. The one we just did right now ended up being proper because every element in A is also in B, but they are not equal, right? They cannot be equal. So since they're not exactly the same, set A is not copying set B, then it is proper. Okay, so I'm hoping that made sense. If it didn't, then just rewind a whole minute, watch it again. But that's a definition. So you guys know what subsets are and you know what proper subsets are. Now here comes the fun because I'm actually going to give you a set and I'm going to ask you to find every single subset. So that's where we're heading. If I give you a set, any set that I want, and I ask you how many subsets are there going to be, you are always and forever going to use this formula. You're going to do 2 to the nth power. The n is going to be replaced by the cardinality of the set. If you don't remember what cardinality means, it's just the amount of elements. So for example, if I give you a set with, let's say 8 elements, then all I have to do is put in my calculator what is 2 to the 8th power, and that's going to tell me how many subsets the set has. Okay, so make sure you write down this formula, put a little star next to it. You're going to be using this one a lot. So as soon as a question asks you how many subsets, you do 2 to the n. So just make sure you remember that. Now, something else you've probably already seen before, but I just want to bring it back, is the empty set. When you are listing subsets of a set, the empty set is always going to be one of them. So the empty set must always be a subset. Believe it or not, I know it's weird, but the empty set is always going to be one of your subsets. So if I have a set of 8 elements, I'm going to have 2 to the 8 subsets, and one of those is going to be the empty set. And again, if you're confused, just hang in there. I know this is a lot to take in, but we're going to be doing an example in a little bit. All right, so here we go with the steps needed for making a list. So I'm going to give you a set and I'm going to ask you list all the subsets. These are the 3 steps you're going to follow. Step 1 is always find out how many am I going to have in total, because you don't just want to start listing and then you're going to have no idea when to stop. So always give yourself a number. So you're going to do 2 to the n. Remember, n is the cardinality. And that's going to give you an exact number of subsets you should have on your list. So if this number ends up being, let's say 8, then I'm not going to stop listing sets until I have a total of 8. Okay, so this is why we always start with step number 1. Once you give yourself a number, step 2, you're going to actually start listing the sets. We're going to start listing sets. Let's start with the baby ones, right? We always start with sets that only have 1 element. And then we move up. We list sets that have 2 elements and then sets that have 3 and so on until we finish, right? So again, if this makes no sense, don't worry. Step 2. And then step 3, once you're done listing or almost done, then you come back and remember what I told you, right? The empty set is always going to be one of them. So we write it down. And then the set itself, the whole set is also a subset of itself. We already talked about it, right? It's not a proper subset, but it's still a subset. So you still have to write it down. So step 1, give yourself a number, calculate 2 to the n. Step 2, start listing with the sets that have 1 element, then the ones that have 2 and so on. And then step 3, always write the set itself and the empty set. Okay, so this is what I mean. I'm going to do one problem here with you. So here they're asking us, list all these subsets of the set below. So we have this set that contains the letters M, A, T, H, right? So very beautiful set because it spells out math. But the elements is M, A, T, H. They're asking us to list all the subsets, all of them. So how in the world do I know when to stop? Well, again, we know the formula. So step 1, we're going to have to calculate 2 to the n. In this case, n, remember, n stands for cardinality. So the cardinality of this set is 4, right? If you're like, oh my goodness, where did you get that number? So you just count, right? There's 4 elements in here. So that's why it's 4. So I put the 4 in the n, 2 to the n. Put that in your calculator or just do it manually, right? 2 times 2 times 2 times 2 gives me 16. So that means that I am not going to finish this problem until I have a total of 16 subsets. Okay, so if you end up or we end up in the list with a total of 14, then something's wrong. We have to have 16. If for some reason you get more than 16, then something is wrong. There has to be exactly 16 subsets. Okay, so step 1 wasn't that bad. Now, step 2, here comes the fun. We're going to have to start listing all these subsets. So, step 2 always says start with the sets that only contain 1 element. So, this is super easy because we just have to list every single letter in a set. So, we're going to start with the ones with 1 element. Super simple. I create a set with just the letter M, a set with just the letter A set with just the letter T, and a set with just the letter H. So look at that. We have 4 down already. Remember, there's a total of 16, so we still need a couple more. But we at least have already 4 written down. Now, since we already created all possible combinations with 1, now we're going to create combinations of 2. So this is the way I do it. If you find an easier way, go for it. We really don't care how you do it as long as you list all 16 subsets. So the way I like to do it is to find the sets that have 2 elements. I start by pairing these 2. So I pair M with A. That gives me the first set. And then I pair M with T. That gives me the second one. And then I pair M with H. That gives me the third one. But of course, we're still not done. Now we have to make more combinations. Now I'm going to pair A with T. Be careful, I cannot pair it with M anymore, right? Because they're already paired up over here. So I pair A with T. That gives me that one. And then I pair up the A with the H. That gives me another set right there. And then the last one I have to do is just pair these 2 together. So I pair up the T and the H. And then look at that. We already made all the possible combinations. So those are all the sets that contain 2 elements. So let me just go ahead and count how many we have already. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So progress. We have 10, but according to step 1, we have to have 16 total. So we're missing 6. But don't worry, we're getting there. So we already did 1 element, 2 elements. Now we're going to do 3 elements. And here's where it starts getting crazy, right? So we're going to have to make combinations of 3. Again, do it however you want. I'm going to show you the way I do it. So what I do is I'm going to pair up the first 3. So that gives me the first set, M-A-T. Now, not to get messy, I'm going to erase this. Now I pair up the first 2, but instead with a T, I pair it with the H. So that gives me the second set, M-A-H. Now, I'm going to ignore the A, just like I did with the T, and I'm going to pair up the M with the last 2. So that gives me M-T-H. And then the last one, I'm going to completely ignore the M. And then I'm just going to pair up the last 3, right? So those get a chance to be without the M. And that gives me the possible combinations with 3. Okay, if I'm losing you, again, you might find an easier way for yourself. Feel free. We don't care as long as you get all the answers, right? So this is what I did here. So we have all the elements with 1. We have all the sets with 1 element. We have all the sets with 2 elements. We have all the sets with 3 elements. So let's do a progress check. Let's see how many we have now in total. We have 1, 2, 3, 4. Those are supposed to be dots. I'm sorry. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Look at that, 14. Again, we're missing 2 because step 1 says that there's supposed to be 16 total, and we have 14. But no need to worry because step 3 says that there's 2 more sets that you don't always forget about. So I'm going to remove this slide. Step 3, remember there's 2 sets that are always going to be subsets. The whole set, so the set itself, you could just copy, paste it. That's one of the subsets. So we had 14 in the last slide. This one is going to be 15. And then go back to step 3. And it says that the empty set is also one of the subsets. So there we go, 15 and then 16. So that is how you come up with a list of all the subsets. And I know what you're thinking, like, what in the world is this, right? It's not complicated. It is going to be kind of maybe a little tedious work. But we did one of the hard ones. I did one with you that has 4 elements. If you have one with 3, it's going to be shorter. If you have one with 5, it's going to be a little longer, but it's the same procedure. So again, just to recap, according to step 1, we did 2 to the 4, which was 16. That is an equal sign, believe it or not. So I was supposed to have a total of 16 answers, and look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's how you get all of your answers. Again, we're going to be doing another one of these right now. So don't panic if you didn't understand it. That's okay. We're going to do another one. Now, I'm going to tell you one quick tip of how to check that you're good. So one of them was checking, or we counted, we have 16. If for some reason, and it happens a lot to me and it might happen to you, you end up with like 15 and you're missing 1 and you have no idea where it is. So you have no idea how to check where it comes from. This is one way, really nice way. One of the instructors in the department showed me how to check. It's super awesome. Organize them like this. Start the one with the empty set always, and then list all your 1 elements, list all your 2 elements, list all your 3, and then list the whole set. And look how cool this is. The empty set, there's 1 of them. And on the whole set, there's 1. So these 2 are always going to have the same amount of answers. Now, for 1 element, we have 1, 2, 3, 4. And for 3 elements, we have 1, 2, 3, 4 also. So these 2 are always going to be the same. And then the one in the middle, if it doesn't have a partner, then that one, 1, 2, 3, 4, 5, 6, it's on its own, right? But this is a nice way to check, because if for some reason, just bear with me, let's say for some reason I would have had a 3 here. Then I know that the one that I'm missing belongs here, because this one should be the same as this one. The same amount of sets should be on each one. So I think it's a nice way to check, especially again, if you're like 1 off and you're like, oh my goodness, I cannot find where the one that I'm missing goes. Put them in this order, check the numbers, and it'll tell you what row is the one that's off by 1. Okay, so if all of these are the same, so the 1 goes with the 1, the 4 goes with the 4, then you might know that this one might be off, right? So you check that one. But again, we counted, we have all 16 accounted for, so we're good. But that's just a little quick tip, and we'll do it again so you see what I mean. So that is the answer for this one. List all the subsets. I know it was tedious work, but it was kind of fun. I'm having fun over here. And you list them all, and that's what you do. Now, the second part to the question, and I went ahead and put them all up there. They're all 16 are in there. I just put them in, I smushed them together. Now, the question is, how many proper subsets? So let's see if you remember what the word proper means. Proper subset means that 1, it has to be a subset, but 2, it cannot be equal to the original set. So all of these are subsets. How many are proper? Hopefully you could tell me, but if you don't, I am going to still spill the answer, right? So I'm just going to go one by one until hopefully it goes into your brain, right? So this little one here, is it exactly the same as this one? No. So this one is proper subset. Is this one the same as that one? No. So it's proper. Is this one the same as that one? No. So it's proper. And yes, I'm going to stop. You don't have to fast forward. You could just do that for all of them. You're going to find out that they are all proper with the exception of this one, right? That one is exactly the same as the one on the top. So that's the only one that is not proper. So if we have 16 total and this one is not proper, how many are proper? Hopefully you could do that computation, and the answer is 15, right? So out of all the subsets we found, all of them are going to be proper with the exception of the one that contains all the elements. So you always just subtract 1. That was fun, right? You just subtract 1 and that gives you the amount of proper subsets. So carry that with you because that is actually the next thing we're going to be talking about. If I ask you how many subsets does a set have, you just have to do 2 to the n. We already learned that. But if I ask you how many proper subsets, you still have to do 2 to the n. But as we just saw on this last slide, you have to subtract 1 because one of them is always going to be exactly the same as the top one. So that's another formula to keep in mind, but it's pretty simple. So again, subsets 2 to the n. How many are proper subsets? You just subtract 1 from that. Okay, so with that being said, let's try a few more. Here we go. So this one, I'm asking you 2 questions. How many subsets and how many proper subsets? So hopefully you could give it a try. I'm going to give you 5 seconds to try it out. And that was 5 seconds. So let's see. Again, first thing you have to do is find the cardinality, right? So we have 1, 2, 3, 4, 5. So the cardinality of my set S, yes, that's an S, don't judge. 1, 2, 3, 4, 5 is actually, they look exactly the same. The cardinality of S is actually 5. So that means that that's the n I'm going to be using. So how many subsets? Remember the formula for subsets, it's 2 to the n. So 2 to the 5 gives me 32. So voila, that's my answer for the first one. We have a total of 32 subsets. Imagine if we had to list all 32 subsets. That would be fun. But yes, we don't have to. They're just asking us how many. So 32. And if you have no idea how to do this, remember 2 to the 5th just means 2 times 2 times 2 times 2 times 2. So 2 times itself 5 times. If you're going to use a calculator, you do 2 and then you use a little caret button, the one that looks like that, and then you put a 5. And it gives you your answer, 32. That's the answer for the first one. Now, the second question is how many proper subsets? So what do you think the answer for this one is? I'm going to pretend you got it right. Yay. All you have to do is just subtract 1, right? So 32 subsets are a total. How many are proper? We just subtract 1, so 31. Wasn't that simple? Super easy. All right, so you should be all good for the next one. Here, I don't give you the set, but I actually tell you how many elements it has. So there is this random set that has 11 elements. Who cares what the set is? That's all you need. How many subsets? You already know. 2 to the 11 power. Oh my goodness, imagine we throw one of those on your test. You would have to list 2,048 different subsets, right? So make sure we're not in a bad mood when we write your test. But there you go. Imagine 2 to the 11th power. But again, they're not asking you to list them, so don't panic. You just have to find how many. So 2 to the 11 is 248. How many proper subsets? You should already know. 2047, right? Because we just subtract 1, always the case. So hopefully this is making sense. That's what you do for these types of problems here. All right, let's try. Oh, look at this. We're going to try one more of the ones we did earlier. So here, when you see this list, then there's no way out. You're going to have to actually list them. So again, let's have fun. Let's do this all over again. This one should be a little simpler because there are just 3 elements in total. So hopefully you remember, what is step 1? Step 1 is always find out how many we're going to have in total. So I have a set with 3 elements. Step 1, I'm going to calculate 2 to the 3rd power because there's 3 elements. So look at this one. This one's not that bad. We are going to end up having 8 subsets in total. So 8 subsets, we're not going to finish until we have a total of 8. So step 1, done. Step 2, let's go ahead and just start listing them. So remember, for step 2, you always start with the 1 element one. So 1 element, we start with just the elements itself. So F is going to be one of them, U is going to be one of them, and it's going to be one of them. That's it. Super simple. Step 2, part B, is create sets with 2 elements, right? So let me erase that. The way I showed you that I like to do it, right? I pair up F with the U, and then the F with the N, and then the U with the N, and I think that's all the combinations you could make, right? Again, don't put N with U because it's the same thing as U with N. So if you have the same elements but in different order, don't do that. It has to be exactly like that. So I think that's it. So let's say in the last step, we found out we had to do 8. Right now we have 1, 2, 3, 4, 5, 6. Again, those are supposed to be dots. So we're missing 2. What in the world are the other 2? If you told me move on to step 3, then yes, you're right. Step 3, remember, don't forget the other 2. There's always going to be 2 that you write at the very end, which is the set itself. So that one's right there. And then the empty set. Don't forget the empty set. And look at that. We did this super fast now because we're experts. Those are the last 2. That gives me all of them, right? And again, just to double check, I count. We have 1, 2, 3, 4, 5, 6, 7, and 8, which is what I got from step 1. And again, if you want to double check the way I checked the other one, look at this. This one has 1. This one has 1. So those 2 are equal. We're good. This one has 1, 2, 3. And then here we have 1, 2, 3. And those 2 are equal, so we are good. And that's how you check. Right, so on your test, on your online homework, if for some reason it's just come up here and this we would have only had 2, that means that this is the row that's missing 1, and you would have to go back and check that you paired them up correctly. But no need to. Here we have all 8 of them, so we're good to go. All right, so that is that. But of course, that's not all of the questions. So they told us list all the subsets. Here they are, all of them. Now, how many are proper? So in your paper, I want you to underline the one that's not proper and write down, this is the one that is not proper. Because again, when you do the online homework by yourself, you want to make sure you have a little note of which one's the one that we took out. So all of these are subsets and all of them are proper with the exception of, I think you got it, that one, right? That one's the only one that's actually exactly the same as the other one. So that's what we call improper, right? So that one's not a proper subset. So how many proper ones do we have? We already know we just subtract 1. So it's 7. So we have a total of 8 subsets. 7 of them are proper. All right, we made it through that one. So just bear with me, we're almost done here. Here comes the fun part. Let's review the symbols. Okay, so these are going to be super easy questions, but just to wrap it up, it's a quick yes or no, right? So this symbol here, what does that symbol mean? That is element of. Is F an element of A? So is F in here? Super simple. Yes, F is an element in set A because it's in there, right? So just practice. All right, next one. Is G not an element of A? Be very careful with this one. Is this true or false? Yes or no? So is G not an element of A? That's true, right? G is not an element of A. It's nowhere to be found inside the set. So yes, G is not an element of set A. Okay, if you got tricked on this one, just again, I was going to say fast forward. Just rewind 20 seconds now. Just read it again. G is not an element of A. Oh my goodness, this is what we saw today. Don't get confused. How do you read that symbol? So that symbol is subset. Is UN, or the set with UN, a subset of A? Remember, subset means do all the letters here come from here? So do they? Yes, they do, right? U and N. So that means that yes, UN is a subset of set A. That's all we care about. We don't care about anything else. Just for subsets, you just ask yourself, do all of these come from here? Okay, so yes, it's a subset. Now, it's not the same question. This one means proper subset. Is it a proper subset? So for proper subsets, you have to check first that all of these are in there, which we already checked. But it cannot be the same set. Is this the same as that, the whole thing? It's not. So that means that it is proper. Yes, it's proper because it's just a piece of it. It's not the whole thing. Okay, so don't get them confused. The last one is just, is it a subset? This one, is it a proper subset? You check that it's not exactly the same as the one on top. So since it's not, there's no violations, we're okay. It is a proper subset. All right, just hang in there with me. 2 more to go. Is NUF a subset of A? Okay, so again, remember for subset, we just have to check that all the letters come from the original one. So let's check that, and that's it. N is there, U is there, F is there. That's all we care about. So is it a subset? Yes, it is. That's all we care about. So yes, NUF or FUN or UFN, whatever. If you notice, I changed the letters around. I'm sorry, but it's exactly the same thing. Yes, it's a subset because every letter comes from the original one. So we're good. Now, don't freak out. Same problem, but with a proper subset. Is NUF a proper subset of set A? So again, when I ask you for proper, there's 2 things you check. First thing you check, do they all come from there? Okay, that condition is met, but there's a second condition. The second condition is that it cannot be exactly the same as the original set. Is this the same as that? Hopefully you said yes, right? Remember, order doesn't matter. Every element in the set that I wrote down is exactly every element on the top. So that is a big no-no. That's a violation. So even though it's a subset, it is not a proper subset. Because remember, for it to be a proper subset, it cannot be like a copycat. It cannot be exactly the same one on top. Okay, so I'm hoping that made sense. If it didn't, go back and look at these 4 last examples. So there's going to be some cases where a set is a subset but not a proper subset. Okay, so my computer just jumped around there. I'm sorry. But again, make sure you look at these 4. If for some reason you still have a question, feel free